Swagatam Kapadi Mathematics classes. Gurubhyo Namaha. This is your Murali Krishna. This is the 7th video on the chapter Trigonometry. Before entering into the regular lesson, let me solve one numerical question. That question is degrees. You have to find the value of this expression. Now, only we know this table. From this table, we can obtain the values of trigonometric ratios of any angle up to 90, 0, 30, 45, 60, 90. Just pick the values of trigonometric ratios from the table and substitute, get the answer. That's all. So you of this expression is trigonometry. Now, the lesson is not solving this question. I want to show how you can solve or how you can find values of this expression using this table if the angle is less than 90 degrees. Suppose in any expression, if I want to find the value of any trigonometric ratio of an angle more than 90, this table is not useful. So in that case, we need some more information. The lesson is how to find the values of trigonometric ratios for any angle of any size. Angle of any size or any sign. Now, the people in some schools or some boards, the students are allowed to use calculator. For them, I think this is not required, but there is a lot of logic behind these trigonometric values. Values of trigonometric ratios of an angle of any size and any sign. Now, let me explain that. So, the lesson is how to find trigonometric ratios of an angle of any size and any sign is the lesson. Okay. Now, to understand this lesson, I need one small. Let the circle is a unit circle in a rectangular system. Unit circle means whose radius is 1 unit. This is the unit circle of radius 1. So it is called unit circle. Now, take a point on the boundary of the circle. Say somewhere, it can be first quadrant or second quadrant or third quadrant or fourth quadrant. Let's say some point here. Of course, its coordinates are x, y. Join OP. Let is equal to A. Angle AOP is equal to let alpha. Of course, again I am telling this point P can be anywhere on the boundary of the circle, and the line OP is making an angle alpha degrees with the x-axis. Draw a perpendicular line from the x-axis. This is here. And of course, you know this is x and this is y and this is 1. From triangle O and B, from triangle O and P, we have cos alpha is equal to x by 1 or simply x. So from triangle same triangle, sin alpha is equal to y by 1 is equal to y. That means the x comma y, px comma y is equal to cos alpha comma sin alpha. P is a point on bounded circle. OP is making an alpha degrees in the positive x-axis in positive direction. Then coordinates of that point can be written as cos alpha and sin alpha. This is very, very important. Okay. Now using this one, the next one is the value of trigonometry ratios for the angles angles 90 minus theta in terms of theta. This is by the lesson. Now, what actually is concept? Now, for this, I take one unit circle in a rectangular system, and you know very well what is rectangular system. O, x-axis, x prime, y, y prime. Let A be the OA be the initial line. OA rotates through an angle theta and reaches the position P. Now, the P coordinates are x comma y. P coordinates are x comma y. This angle is equal to theta. Draw a perpendicular line from B to N. Therefore, my ON will become x, my PN will become y, and is equal to 1. So, from triangle OPL, we have cos theta is equal to x by 1, sin theta is equal to y by 1. Therefore, P coordinates x comma y is equal to cos theta comma sin theta. This is normal thing. Now, what's about angle 90 minus theta? What is the meaning of this one? I want to find the position of the P on bounded circle when the angle is 90 minus theta. For this, what we do? Now the OA rotates to OB. If do so, OA is making 90 degrees angle. After reaching OB, I bounce back 90 degrees. I bounce back theta degrees. I bounce back theta degrees. Like this. That means if this is theta, then automatically this angle will become 90 minus theta. Let this is equal to P1. So my OP1 is making an angle 90 minus theta with the x-axis. As per the concept, the P1 coordinates are now OA angle AOP1 is equal to 90 minus theta. As per the concept, the P1 coordinates are I have cos of 90 minus theta and sine of 90 minus theta. Okay, now draw a perpendicular line from P to y-axis. Let this point is N1. Now OPN, the triangles OPN is congruent to triangle OP1N1. How? Very simple. These two angles are numerically equal, and this is 90 degrees, this is also 90 degrees, and OP1 is equal to OP. By side angle property, that means angle ASA property, these two are congruent. When these two are congruent, corresponding sides are equal. What are the corresponding sides? My PM is equal to P1 N1. My ON is equal to my ON1. Therefore P1 N1 is equal to PM, and whereas ON1 is equal to ON. Now, for the point P1, N1 P1 is the x coordinate and ON1 will be y coordinates. Then coordinates of P1 will become y1 comma x. y1 comma y comma x. Therefore P1 coordinates are y comma x. Very simple. The P coordinates x comma y, then P1 coordinates will become y comma x. An angle rotates 90 minus theta. Y comma x. Okay, but y comma x is equal to, we have y is equal to sin theta, and there x is equal to cos theta. But P1 coordinates are cos of 90 minus theta and sin of 90 minus theta. Therefore, this cos of 90 minus theta will become sin theta, and sin of 90 minus theta will become cos theta. Therefore, cos of 90 minus theta is equal to sin theta, and sin of 90 minus theta is equal to cos theta. Based on it, you can find what is tan of 90 minus theta, what is cot of 90 minus theta, what is secant of 90 minus theta, and so on we can do. So, if OA makes an angle of 90 minus theta with the x-axis, and its coordinates are x comma y will become y comma x. So based on this relation, I have cos of 90 minus theta is equal to sin theta, and sin of 90 minus theta will become cos theta. Please take it. The next one is the values of trigonometry ratios for the angle 90 plus theta in terms of theta. So for this, what I do, already I know the angle between OA and OB is 90. I further move another angle of theta, so that the angle, the new position is, say for example, P2. Angle AOP2 is equal to, angle AOP2 is equal to 90 plus theta. Angle AOP2 is equal to 90 plus theta. Okay, now I depends on the congruency. Here ONP and ON1P2 are congruent again. Then this coordinates also will become y comma x. But this x coordinate is numerically y is along the negative x axis, So it becomes minus y comma x. Therefore, P2 coordinates are cos of 90 plus theta, comma sin 90 plus theta is equal to minus y comma x. But my y is equal to sin theta, x is equal to cos theta, is equal to minus sin theta, comma cos theta. Therefore, my cos of 90 plus theta is equal to minus sin theta, and sin of 90 plus theta is equal to cos theta. Next one, quickly I go to next angle. Next angle is for 180 minus theta. For 180 minus theta, for 180 minus theta, again angle OA reaches to OA prime, that means it is making 180 degrees with the x-axis, and I go back theta degrees angle, so that this angle will become 180 minus theta. So my OP3, my angle AOP3 is 180 minus theta. So my coordinates of P3 are angle AO P3 is equal to 180 minus theta. Therefore, my P3 coordinates are cos of 180 minus theta and sin of 180 plus theta. Okay, now draw a pattern line that is equal to N2. Now N2P3 are congruent with each other. Based on the congruence law, this will become again x comma y. But this x is along negative x-axis, so it becomes minus x comma y. That means when OA rotates to 180 minus theta, the point Px comma y will become minus x comma y. So is equal to minus x comma y. But x is equal to, we have cos theta, and y is equal to, we have sin theta. Now comparing these two, we have cos of 180 minus theta is equal to minus cos theta, and sin of 180 minus theta is equal to sin theta. Yeah, please take. Quickly, I will make a list of the values for 180 plus theta, 180, 270 minus theta, and so on. So, position P4, we reached up to P3. Position P4 is angle AO. P4 is 180 plus theta. Therefore, P4 coordinates are cos of 180 plus theta and sin of 180 plus theta. And cos of 180 plus theta, sin of 180 plus theta, based on the congruency, it will become minus x comma minus y. Coordinates are minus x comma minus y. And it is nothing but minus cos theta comma minus sin theta. That means cos of 180 plus theta is equal to minus cos theta, sin of 180 plus theta is equal to minus sin theta. Whereas angle AOP5 angle is 270 minus theta. For 270 minus theta, my coordinates will become minus y comma minus x. X will become y become x. So my P5 points are cos of 270 minus theta, sin of 270 minus theta. Based on the comprehensive, I get minus y comma minus x. And whereas minus x is equal to, you have minus sin theta and this is minus cos theta. Actually, I go to the next one. This is P6. P6 coordinates. Angle AO P6 is equal to, I can go. Therefore, P5 coordinates are cos of 270 plus theta and the sin of 270 plus theta, and the coordinates will become minus y comma x is nothing but minus sin theta comma cos theta. And finally, I go to this angle. This is nothing but P7. P7 angle AO P7 is equal to, I can write 360 minus theta. So P7 coordinates are cos of 360 minus theta and sin of 360 minus theta. This will become, this one will become x comma minus x comma, sorry, plus x comma minus y. Why? Because coordinates. Minus y comma x will become x comma minus y. So here x is nothing but cos of 360 minus theta is equal to cos theta minus sin theta. Now suppose if I go further theta, now this angle will become 360 plus theta, and 360 plus theta again is in first quadrant. Same thing we can have. So if the angle is 360 plus theta, then we have P and P8 both will coincide. I will get cos of 360 plus theta comma sin of 360 plus theta, which will become cos theta comma sin. So this is the list. Remembering the procedure is really tough. Instead of that, I will tell you one technique or one trick how to find values of trigonometric ratios of an angle of any size and any sine. For this, I take again rectangular coordinate system. Please listen carefully. This is my positive x-axis, negative x-axis, negative y-axis. And you know very well this angle in this first quadrant, all the ratios are positive. That means sine all are positive. Whereas second one, its name is silver. That means sine and cosecant are positive. Next one, this is in this one we have t. T means tan and cot are positive. Whereas this is cos. And here cos and secant are positive. Now the angle between OX and OY is 90 degrees. If you take any line between OX and OY, that the angle will be less than 90, right? So that is only the symbol 90 minus theta. So 90 minus theta is in first quadrant. Okay, when you cross OX, the angle will become 90 plus theta. Why? Because it is more than 90 degrees. Now, if we take any line between OX and OX prime, that is definitely less than 180. So, that is denoted by 180 minus theta. So, if 180 minus theta represents that line lies between OX and OX prime. Once you cross this one, this angle will become 180 plus theta. And of course, this is 270 minus theta, and this is 270 plus theta. And whereas this is 360 minus theta, and of course this is 360 plus theta. I don't think 90 minus theta here. And this is 360 plus theta. In every quadrant, we have two angles. First one is 90 minus theta, 360 plus theta. 90 plus theta, 180 minus theta. 180 plus theta, 270 minus theta. 270 plus theta, 270 minus theta. 360 plus theta, 360 minus theta. Now, how to find? Just now we derived for 90 and 270 degrees. So 90 and 270 degrees, x coordinate is becoming y coordinate becoming x coordinate. So based on that one, whenever you suppose I want to find sine of 90 plus theta, I want to find. Now first of all, I observe this 90 at angle 90. Whenever you have 90 degrees or 270 degrees in this position, 90 degrees or 270 degrees in this position, my sine will convert into cos. My cos will convert into sine. My tan will convert into cot. My cot will convert into tan. And my secant will convert into cosecant. My cosecant will convert into secant. Please remember this point. Next one, second one, whenever you have 180 degrees or 360 degrees in this one, x will remains x, y will remains y, only signs will change. So, I write here same ratios. It is just a technique, it's a trick. Remember this one. Now, with the help of this concept, if you observe carefully, for 90 minus theta we have 6 formulae. For 90 plus theta we have 6 formulae. So here like this, 1, 2, 3, 4, 5, 6, 7, 8. 8 angles. For each angle, 6 ratios. So 8 into 6. That will be 48 formulae. If you remember this table, generating any one of these 48 formulas is very easy. Now, come to the lesson. Now, listen carefully, it's very easy. I want to find, I'll come to sine of 90 plus theta. Sine of 90 plus theta. Because of 90, the comes under this is the sine will become cos. So please write first of all cos theta as this. So sine of 90 plus theta will become cos theta. This is step number 1. Step number 2, 90 plus theta lies in second quadrant. 90 plus theta lies in second quadrant. In second quadrant, my sine is positive. Again repeat, 90 plus theta lies in second quadrant. In second quadrant, sine is positive, so put plus sign. So sine of 90 plus theta is equal to cos theta. Now, I want to put another example. Say for example, I want to do tan of 360 minus theta. Now 360 comes here. X remains X, Y remains Y. So whenever 180 or 360 given, the result is same ratio. That means here tan is given, it produces again tan theta. Because of 360, the tan transformed into tan. Step 2. 360 minus theta lies in fourth quadrant. 360 minus theta lies in fourth quadrant. In fourth quadrant, tan is negative. So my answer is tan. Negative. So tan of 360 minus theta is equal to minus tan theta. Let me do one more. I want to find secant of 180 plus theta. Secant 180 plus theta, because of 180 comes under here. That means same ratio. So secant will transform into secant theta. Step number 1. 180 plus theta lies in third quadrant. In third quadrant, only tan and cot are positive, not secant. So in 180 plus theta lies in third quadrant. In third quadrant, secant is negative, so I get a negative sign. So using this technique, you can generate any one of the 48 formulae is taken. So this table name is all silver tea cups table.